Every device on this planet talks to the internet through the same invisible doorway. And if you cannot build that doorway yourself, you will always be dependent on someone else's library to do it for you. Today, you build it from scratch with raw Python sockets. Nobody teaches this the right way. Courses throw frameworks at you. Requests, HTTP libraries, Flask. But underneath all of that, the internet is just two programs sending bytes to each other over numbered ports. When you understand sockets, the entire network stops being magic. You will see exactly how your browser, your database, and every exploit on the internet actually move data. And that understanding is non-negotiable if you ever want to work in cybersecurity. A socket is the endpoint of a two-way communication link between two programs. Think of a phone line. Your program is the phone. The socket is the handset, the thing that actually opens the line, dials, and carries your voice. The network stack underneath it is the telephone company, and you never need to see how it routes your call. You just need to know 3 numbers to make it work: the family, the type, and the port. Those 3 numbers become real code. Socket.socket takes 3 arguments: family, type, and protocol. The family tells Python which addressing scheme to use. AF_init means IPv4, the addressing you already know. The type tells it how data is delivered. Sock_stream means TCP, a reliable, ordered connection, the one used for almost everything. And the protocol? For TCP, it is usually 0, which tells the OS to pick the correct one automatically. Right now, you don't memorize these by heart. You memorize one pattern you will reuse forever. Every network conversation has 2 roles: a server that waits and a client that dials. The server creates a socket, binds it to a port, listens, and accepts. The client creates a socket, connects to an address and port, and talks. 4 verbs on one side, 1 verb on the other. The whole protocol boils down to this handshake. Here is the anatomy of the server, line by line. You create the socket, you bind it to a host and port, you listen for connections, and then you loop, accepting each incoming client, receiving bytes, decoding them, and echoing them back. 300 milliseconds of setup, and you have a working network service. Let me walk you through the logic before you run a single line. The socket is your door. Bind nails it to a specific port on your machine. Listen puts a guard there. Accept blocks. It sits there waiting until a real connection knocks. Receive reads up to 1024 bytes off the wire. And send pushes your answer back. That's it. Everything a web server does, this loop does. The client is simpler. 1 connection, 1 send, 1 receive, 1 close. Run the server in one terminal, run the client in another, and watch the bytes travel from one process through the loopback interface at 127.0.0.1 and back again. 127.0.0.1 is your own machine, the localhost. It is the safest place in the world to learn this, because no packet ever leaves your computer. The reason most beginners get stuck here isn't the code, it's the mental model. Sockets are blocking. When you call accept, your program literally pauses until something connects. When you call recv, it pauses until data arrives. That is why real servers spawn threads or use an event loop, because a single blocking socket can only serve one conversation at a time. You are building the primitive first. Production engineering comes later. Now, where does this actually show up in the real world? Every port scanner on Earth, from Nmap down to a 15-line script, runs on this same primitive. Connect to a host on a range of ports and see which ones answer. That is reconnaissance. It is how attackers map a network, and it is how defenders inventory their own attack surface. Same raw socket, 1 loop, 5 lines. ConnectX doesn't throw an exception on failure. It returns an error code. 0 means open. That is the entire trick. I'm showing you this so you understand the mechanism, not so you run it against machines you don't own. Scanning systems without permission is illegal in most jurisdictions. Use it on your own lab, your own localhost, or a platform built for this, like HackTheBox or TryHackMe. Defenders need this logic to find their own open ports before attackers do.